Hey guys, my name is Brittany Lappel and I am the technical docent for Clemson School of Architecture. Today I'm going to be showing you a few of the basic features of Revit using an example we all know and love, our second home Lee 3. I am going to create a very generic model just to keep things as straightforward and concise as possible. So let's go ahead and get started. When you open Revit, this is the home screen. Unfortunately, my screen record doesn't like to cooperate with the pop-up dialog boxes within Revit, so I will be verbally walking you through what I'm doing in those moments. Luckily, it's not anything too complicated. We are going to go ahead and select Model, then New. When you select New Model, you are given several template options. The one you'll use most often will be Architectural, which focuses on spatial design, whereas the other templates are generally used for structural or building system design. Once selected, you will be brought to your Level 1 floor plan with 4 standard building elevations already in place. Rather than go off of memory, we're going to look at how to import and scale a pre-existing plan of Lee 3, which is something you may find yourself doing fairly often at your internship. You would do this for a number of reasons, most likely for a project that involves an existing structure or any rehabilitation renovation project. You start by selecting the Insert tab and then Image. Bring in your desired JPEG drawing and drop it in place. The catch here is that you do need to know the scale of the drawing, but if there isn't one included like we have here, you can always go based off of a known dimension. Worst case scenario, you could use a standard dimension such as a door frame. To scale, select the image and then the scale icon in the toolbar. Click your first point and then the second, and then type in that specific dimension and click Enter. Go ahead and double check to make sure it's accurate using the ruler tool. Once finished, we'll pin the image in place so that it doesn't move on us while we're working. We're going to work from the bottom up in this project, so let's use the scale plan to create a basic floor. I'm going to use the generic 12-inch floor. Again, I will be using all preloaded elements today just to stay out of the weeds of the program. We're going to go ahead and trace the outline of the building. To cut a section, you go to the View tab, click and drag where you want the section to be. You can change the direction the section is facing, as well as edit your view depth. Open the section and drag the extents of the window to what you want to have visible. The section view is the easiest way to edit your floor levels, as well as create new ones. For example, we're going to change the second floor to be 12 feet. To add a new level, select the Architecture tab and then the Levels icon. You would simply click and drag this tool across the screen and section in order to create a new level and adjust the height the same way we just did. Going back to our Level 1 plan, we're going to select the slab and temporarily hide it in view to make our floor plan visible as we move forward with the walls. You will navigate to the Architecture tab, then select Walls, Architectural. We need to first measure to see what the wall thickness is that we need, and it looks to be roughly 3 feet. So select the generic 12-inch wall option, and then we will edit type. Again, the dialog box that will appear is not visible on my screen. So the point I want to emphasize here is whenever you edit type, whether this be for walls, floors, etc., always make sure to duplicate first. Otherwise, you will override all existing elements in the project. So here I'm going to duplicate the 12-inch wall type, rename it to 36 inches, and change the wall thickness in my invisible dialog box to be 3 feet. I will then trace the west exterior wall and do the same for the opposite. The placement of the walls is finicky. Always make sure you know what your location line option is set to, which you can find on the Walls toolbar in the center of the screen. I'm going to use a simple detail line and angle tool to make sure my wall is set to a clean number. For the unique wall conditions, we are going to create our own model through a simple extrusion. You will select Component, Model in Place, scroll down to Wall when prompted, and then we will model an extrusion. We trace over the floor plan and adjust the height in 3D perspective and section. I will also go ahead and change the level to a height that looks slightly more accurate. There are several tools in Revit that you can use to simplify the process of repetitive elements, one of them being the mirror tool. I'm going to use Annotate, Line, then Center Line, and mark the center of the plan horizontally. By doing so, I can select the north wall element, select the mirror tool, and then the center line, and it will fall into place accordingly. Next, we will work on the glass facade. Return to the first level plan and trace the south wall using the preloaded storefront option. This wall type will create a standard grid of vertical and horizontal mullions. The mullions can be adjusted by tabbing through until you can select the grid. Unlock the grid and then use the Move tool to adjust accordingly. This is done more easily in elevation. Again, you tab through until you are able to select the grid, unpin, and change to the desired dimension. When the grid line is selected, you will also have the option to add or remove a curtain grid. To create a door, start by selecting the bottom mullions, unpinning and deleting. Tab until you can select the glass panel and then unpin it. We will need to load in a Revit family for a standard glass double door. You navigate to File, Open Family, and Revit's preloaded list of families will appear. We're going to select Doors and then the option that we are looking for. Once open in Revit, select Load into Project in the upper right-hand corner. Once back in our file, we can once again select the glass panel and change it to our newly imported glass door in the Properties panel. Moving into the interior, I am going to start with the stairs. We are going to first trace the existing plan with our generic 6-inch wall height. Then we will select Architecture and then Stairs. We will use the precast option in this model. I'm going to quickly count the number of risers and adjust the Properties panel accordingly. Revit stairs are smart and know the standard codes for rise and run and will prompt you to change the level heights based on what is needed for your stairs. By clicking and dragging, it will automatically place the stairs, and if you select again and move your mouse, Revit will add a landing. All we need to do is double check widths and adjust our wall spacing to accommodate. Next, I will edit the wall heights and delete the railings to imitate Lee 3 as closely as possible. The interior walls are similar to what we did on the exterior, so I will move through these more quickly. It is important to pay attention to the individual wall heights in the Properties panel. Some walls can span the height of both floors, but others are specific to the level. Next, we will repeat the process of creating a floor, this time for the second level. You want to be in the level 2 plan, and we will select floor and once again select the generic 12-inch option. We are going to trace the existing plan. Through repetition of all the steps gone over so far, we are able to create this basic interior representation of Lee 3. Next, we will move on to probably the most distinctive element of Lee, its curved roof and corresponding structural elements. Although there is a roof tool in Revit, we will instead model a unique roof component. Whenever you're designing a roof that may not follow traditional construction methods, I find that it's easiest to model the roof as a component. There tends to be more flexibility, but as you can see, it usually requires a bit more of trial and error as well. For the Lee 3 roof, I decided that the blend tool may be the best option. This tool allows you to draw two separate profiles in elevation and then seamlessly blends them together. Another useful feature is the Attach Detach tool. When a wall is selected, you can use this tool to merge it with the roof above. Here we will do that with both of our glass facades. For the next portion of this video, we are going to create Lee's distinct skylights as a family. To do so, we will navigate back to our Revit home screen, but this time select Family and then New. You will be prompted to select the family type. For our skylights, I select Generic and then Roof-Based. This is important because it will allow us to insert this family directly into our roof component. I try to keep families as simple as possible. Typically, they're more for representation and can be detailed further in the main model. If there is a unique, repetitive element within your model, you may consider modeling it as a family. This is usually a good way to save time, as well as gives you the option to reuse the family in a future project. Back in our south elevation, we are going to backtrack for a moment and focus on the tree-like exterior columns that make Lee's facade so unique. We will once again model a component. To reiterate, select the Architecture tab, Component, Model in Place. We are now going to use the Sweep tool, which projects a profile along a single path, and then we will mirror it over to the mullion center line. First, I use detail lines to help delineate where I will be pulling the path lines to. We are going to draw the path in elevation, and then the profile has to be drawn in a perpendicular view, which in this case will be plan. I will just use an 8-inch diameter circle, select OK, and then mirror the first column over the grid line. Another great tool in Revit is Copy, which allows you to select an element at a specific point and will duplicate this element and place it at a second point. Going back to our family model, we are going to select the Load into Project option in the upper right-hand corner. In our main model, we can use this component tool once again, but this time we will select Place a Component. The skylight will be the first to pop up. To place the skylight, I'm going to create a new plan view. I do this by duplicating one of the existing levels. I then rename it to Green Roof and use the View Range tool in the Properties panel at the left to change the upper extents to be 35 feet above finished floor, because I know this will be sufficient to see the family above. I then use the Move tool to center the skylight on the interior column and do the same for the next two. Through repetition of all the steps previously discussed, we are able to create a simple representation of Lee3. Although this tutorial really focused on introducing you to a few of the basic tools in Revit, I hope that it also demonstrated you do not need an in-depth understanding of the program to use it successfully. Moving forward, please feel free to reach out to any of the docents and we would be happy to answer any further questions or elaborate on any of the steps you saw here today. Thank you for tuning in.